Okay, let me go for the disk itself. So this is a disk now. A thin disk, chapati, very good example. Because these are the objects what, of course, rigid body we are discussing. We are discussing for rigid body. Chapati is not a rigid body. Just I made you to imagine that one. Okay, the thin disk, you know. What is the moment of inertia about an axis passing through its center and perpendicular to plane? Then it's a like a laminar body, no? It's a laminar body. So then we define sigma equal to mass of the body m by pi r square. This is the area density, that one. Earlier we lambda, mass per unit length. Here sigma, mass by area. What is surface area of this? M pi r square or pi r square. So sigma is what? Kg per meter square. Area density. It was mass, kg per meter. Volume density, kg per cubic meter. So different types of rigid bodies, you should define that densities properly. Okay, now how to get that one? So shall I assume that the thin disk made up of rings? It is just made up of a ring. I'll assume that this thin disk made up of a ring, that one. So here I'll assume a distance r. So let the radius of the ring, let it be r, capital R. Thin ring, I'm assuming it. Then what is the width of this? Will be dr. There's a plane diagram. There's a 3D diagram. The plane diagram will appear like this. What is that thin disk? The thin disk will be this one. This is r. This is what? The width dr. And this is the radius, capital R. Now, what is the total mass of the disk, capital M? What is the mass of this thin elemental ring, dm? This is what? Elemental ring. Already, I think we have come across in center of mass. So, how you define dm? Dm should be equal to, what is the area? Sigma into dA. So, 2 pi r dr. Then you take the whole mass of this elemental ring at what distance? At a distance r from the axis. Then what is the moment of inertia? Dm into r square. Sigma 2 pi r dr r square. So 2 pi sigma r cube dr. So any integration now? S 2 pi sigma, all they are constant. So r cube dr. So this will be 0 to high, 0 to capital R. So where the mass is present from 0 to capital R, the mass is distributed. Then finally, I'll get this equal to 2 pi sigma r to power of 4 by 4. 2 pi sigma is what? M by pi r square. R to power of 4 by 4. M by pi r square. Pi get cancels. Mr. Can you hear me?
Yes, sir.
Yes, and
Yes,
some
sir.
power gone. Okay, we'll continue with the mobile data. This will become how much finally? M r square by 2. So what is the moment of inertia of the disk about an axis passing through center perpendicular to plane? So let me call this axis y y dash. So finally, what is this will be axis will be passing through center and perpendicular. If you want to write I y dash, I think you must be clear that one about axis. So what is this? Mi of this about an axis passing through center and perpendicular to plane. Like this, we'll get a cone. We should do for different objects here. So now once, see, now, see what is use of parallaxis theorem. Finally, what happened, our main focus is how to use parallaxis theorem in different cases here. So this is about the axis passing through center perpendicular to plane. Now let me bring a situation. This lies in xy plane with origin at the center and having a mass m. This is the origin. Now I want moment of inertia about what? About the axis passing through point P and perpendicular to plane. Or this, there's a plane diagram. The 3D diagram will be like this. So this is that axis. And this is the axis passing through O. So this is the point O. This is CC dash. And this is what the axis about point P. This is a point P. So what is now our question now? About an axis passing through point P and perpendicular to plane of the disk. So shall we do one thing? Shall we go for integration? I think we'll be in big trouble. Huh? So what is the axis? Axis is passing through point P and parallel to that axis. So the axis will come like this here. Then what we should assume here is some strip, an arc. Then first I should find out the moment mi of that arc. Then I should integrate. Very lengthy calculation that I can avoid just by using parallaxis theorem. So look at these two axes, CC dash and PP dash. They're parallel. So what is the question now? Find mi. Find mi of disk about axis passing through point P and perpendicular to its plane. So what is the mesh method? There are two approaches are there. What is another approach? Other approach is what? Something you should assume a strip like this. First find out moment of inertia about axis passing through point perpendicular plane of this strip. Arc, or you can call like a some arc, part of a circular, like a circular strip, or just you can call arc. Then you should integrate it. So this will be really big trouble. So this mathematics now I can minimize with the help of parallax theorem. So what is the parallax theorem? Says that IPP dash IPP dash should be equal to ICC dash plus M into what is the perpendicular distance between them? OP, I'll write it. Later on I'll substitute R. So this should be equal to M R square. Just now we derived it. M into this is R square. So how much it is? 3M R square by 2. I think the mathematics we avoided, no? So there's the advantage of this parallaxis theorem. If you know moment of inertia about any one axis, you can easily find out moment of inertia about any other axis with some limitations. Sir, if axis PP dash not parallel to CC dash, okay, don't use parallaxis theorem. So strict condition PP dash must be parallel to CC dash. So getting this one, no, it's all about parallel axis theorem, perpendicular axis theorem. How well you are going to apply it. That's all. Everything about numerical. Now, no. Okay, sir, I got about axis passing through point P perpendicular to plane. Now I want about x or y axis. So this x and y axis will become like diameter, no? Can we find out about x axis? About an axis passing through center. About x axis, I'm telling this one. About this axis, I want. So again, what we should do? Again, we should take help of integration. So is there any other approach we can apply here? So I'll introduce one more theorem called like a perpendicular axis theorem. I am directly focusing more on that one. So once you know parallax perpendicular axis theorem, now you take any rigid body about different axes you can find. In books, what happened? First they're shown for rod, disc, different shaped objects. Then they come to parallax perpendicular axis theorem. So from the beginning only, get habituated for these theorems. So next one is perpendicular axis theorem.